Hi, welcome back to week 8 for Introduction to Logic. We've been talking about rules of replacement, and we've covered in the last two parts, we've covered just about all of the rules with the exception of one of the rules of replacement, which we're going to do here. And this is the rule of equivalence. So you probably would have guessed this already, but there is a correspondence between the syntactic version of equivalence and the semantic version of equivalence. And in particular, you'll notice that when we have this syntactic view of equivalence, we can actually characterize it in the following way. So we said, as part of our strategy for proving or deriving an equivalence, we said, look, what you need to do is you need to first assume P and then get Q. And then in a separate subderivation, you need to assume Q and then get P. And if you do that, then you can introduce the biconditional, right? And that's actually just the biconditional introduction rule. Now, what this is basically saying is the syntactic version of the argument that I just gave. So this just says, if P then Q and if Q then P, then you can just replace that with P if and only if Q, and vice versa. So if you ever have a sentence like this, you can replace it with the sentence like this, keeping in mind again that P might not be an atomic sentence. It might be a complex sentence, so it might be another conjunction where you would just replace that conjunction that maybe is in P with these other occurrences of P. Similarly, we also have it that you have the biconditional P if and only if Q can be replaced with this sentence. And this might be a little bit less intuitive. So here it says we have P and Q or not P and not Q. So I thought, since the second one is a little bit less intuitive, I thought I'd spend a little bit of time and actually derive this for you, and we'll do it actually in both directions, just for the sake of being thorough. Excuse me. So let's go ahead and do that. So we're going to, in the first case, assume P if and only if Q, and then we're going to try to derive this. And I'll be honest with you right now, I haven't actually worked this out beforehand, but I know, given that the book has told me that these are replacement rules for SD+, I know that they have to be. So I'm just going to convince myself that they are, in fact, a truth-preserving rule. So let's just move that out of the way, and let's go ahead, and this is going to be equivalence. Oh, that's a terrible E, but you'll have to just live with that. Okay, so I'm going to do the first direction. So I'm going to assume that we have P if and only if Q. And if you recall here, the goal is going to be the second part. So this is a disjunction where we have P and Q as one disjunct, and as the other disjunct we have not P and not Q. And again, if we think about this intuitively, this is saying, look, either both P and Q are true, or both Q and P are false. So we'll write down here then, we have P and Q, and I'm just again using this wedge here as short form for the ampersand, or not P and not Q. So this is my goal. Now, right from the get-go, it seems tempting that I'm going to try to do something with disjunction elimination. But don't be tempted by that strategy when it's the goal that is the disjunction. When the primary assumption is a disjunction, then you should use the disjunction elimination. That's strategy where you do proof by cases. So when we go in the other direction, right, when we next time assume this and we're going to derive that, then we'll probably make use of the disjunction elimination at some point. But in this case, we're not going to do that. What I need to do is introduce this whole sentence. And my strategy is going to be negation elimination. I'm a big fan of negation elimination, and not everybody is, but that's one of the first proof strategies that I use when I do my derivations. So I'm going to try to get this last step by doing negation elimination. And so what I need to do then is assume the negation of this whole sentence, and I'm going to try to derive a contradiction. So I'm going to take not, and I'm going to go, I need a second parenthesis. I'm going to go P and Q, or not P and not Q. Hopefully this isn't too confusing. So this should really be the wedge, right? This is and here. I think it's a little bit clearer there. And this is a negation. Okay, so you might have thought, well, Bert, why would you do that to yourself? Because you've now put this negation out in front of this whole thing, and that's not going to be very much help in terms of like taking things out of here, right? Because I've got this negation out in front. Well, the reason why I've done this is I'm going to try to build this inner sentence so that it contradicts with this big outer sentence, right? With this big negation. So what I'm going to try to do is at some point try to get P and Q. Or alternatively, I'm going to try to get not P and not Q, and then going to tag on the other disjunct to then try to get the contradiction. So my sub goal in here is going to try to get a contradiction of some kind. And I think my best bet is going to be to try to get, I need to build this sentence, right? So at some point, and this is the part that sometimes, admittedly looks weird and I think confuses people and gets them frustrated. But you have to understand that when you're in a different scope line, you're under different assumptions. And so although the strategy doesn't seem, to make intuitive sense on one level, when you think about how these derivations work, you start to see that no, actually, they do tend to actually make a lot more sense than I initially thought. So my goal here is to build this sentence, which, incidentally is also the one I want. But here I'm going to try to build this sentence so that it contradicts with this negation so that I can actually get the sentence that I want. And the idea is I'm going to have to use some auxiliary assumptions to actually try to build this sentence. So I'm going to be wanting to make use of other assumptions. So one of the ways I'm going to try to get P and Q might be to actually get the negation of it. So I might do something like P and Q, and I would assume the negation of that. Oh, actually, sorry, that's not what I want to do. Sorry, let me backtrack. My goal is to actually try to get some kind of contradiction, right? So what I'm actually going to try to do is get not P in one of these cases. And here's the thought behind this. Up here, I have a biconditional, and I can make use of the other. I can make use of this if I were to also have P, or alternatively, if I were to have Q. So I can't make use of it just as it is. But if I try to make my goal not P, and I do that by negation introduction, then I know I'm going to have my assumption available to me as P. So I could make this assumption for the purposes of negation introduction. So here, notice, now that I've got P, I can actually get Q out. Right? Because I have P under this auxiliary assumption, and I have this biconditional. So I have P if and only if Q. Then what I can do is I can use biconditional elimination on lines 1 and 3 to get Q. So this is biconditional elimination, citing line 1 and 3. And you might think, well, okay, well, why am I getting that? Well, remember one of the things I said I want to do is I want to get some traction by trying to build contradictions. And notice here, if I can have P and Q, I can just tag on this other disjunct, in which case I have a sentence that contradicts this whole sentence up here. So that's what I'm going to do. So I'm going to have P and Q. Then I'm going to do that by conjunction introduction. I'll just move it out here so it's a little bit clearer. From line 3 and 4. And now I can use disjunction introduction to just get the second half out, right? So I could do P and Q. And remember, whenever you've got a sentence, you can tag on whatever you like. So in this case, I'm going to make this right disjunct. I'm going to make it not P and not Q. I'm allowed to do that, right? Because disjunction introduction is a truth-preserving rule, and I can always add onto any sentence that I've derived in that scope line, I can add on any other disjunct I like. And now I have a contradiction, right? This sentence here, line 6, contradicts line 2. And I'm not going to reiterate line 2 down here because that'll be a little bit too much work. But hopefully you see that, right? That this sentence here contradicts this sentence up here, which is exactly what I wanted to get in the subderivation. So by assuming P, I got a contradiction. So now I've gotten not P, and I've done that by negation introduction, citing line 3 to 6. So now I've got not P, and hopefully it's becoming a little bit clearer for why I would actually want to do that. You'll notice if I have not P out here, if I could also get not Q, then I could build the conjunction, introduce this disjunct, right? So do disjunction introduction, get this disjunct, so then I'd have this whole sentence in this main scope line, which is what I want down here, and that would contradict with this sentence here, sentence number 2. So I'm going to put line 7 here. So my goal now is to get not Q. And again, the reason why I said I wanted to use not Q is because I'm going to use as the second last step, I'm going to do not P and not Q. I'll be able to get this last line now by disjunction introduction. I'm not sure what this line is yet, but I'm going to use disjunction introduction to add on this other P and Q, which will then contradict with this big sentence up here. So I know that if I can get not Q, then I can get the conjunction not P and not Q. Then I can do by disjunction introduction, I can get P and Q tagged onto that, which contradicts my auxiliary assumption, which means I can do negation elimination to get this whole sentence out. So, this is admittedly somewhat confusing, right? Because we're using negation eliminations, negation introductions everywhere, trying to find contradictions, and it's definitely not as intuitive as you might think. Which is why, for what it's worth, we're now moving away from SD, right? Because the only rules I'm helping myself to here are the rules that are in SD. The rules of replacement are going to allow me to go straight from 1 down to this last one, right? I'm not going to have to do any of this sort of crazy negation introduction, negation elimination sort of manipulation. But it's important to sort of see how you actually can do this in our system SD. So, now that I went off that little bit of a tangent, let's go back and refocus here. So my sub-goal now is to get not Q. The way I'm going to try to get not Q, given that it has a negation out in front, is to try to use negation introduction. To do that, I assume that Q is the case for the purposes of negation introduction. Right, so this last line will be a negation introduction. And what I need to do now inside this subderivation is to try to build up a contradiction. And I'm going to use almost the exact same strategy that I did up here, but starting with Q instead of with P. So notice that now that I have Q, I can actually go back and make use of this primary assumption I have, this biconditional. Because I have Q and I have this biconditional, I can actually take out P by citing biconditional elimination on lines, oh, it's not a very good E, biconditional elimination on line 1 and line 8. Now that I have P, I can use the same strategy that I did before, right? I can conjoin P and Q, right? So I can get the conjunction by setting line 8 and 9. So this is by, let me just be out here to be a little bit clearer, so I don't mark up into that line of justification too much. So we have conjunction introduction from line 8 and line 9. And then I can, remember, disjunction introduction lets me introduce anything onto what I've already derived. So on line 11, I'm going to add to P and Q. I'm going to add another disjunct. So I'm going to use disjunction introduction, and I'm going to add not P and not Q. And this is by disjunction introduction from line 10. Okay, and now we'll notice that 911 contradicts line 2. So we have the contradiction that we were seeking in the same way as we had the contradiction that we're looking for up here, right? So this is the strategy we used in this subderivation. That's exactly the same strategy we've used here. So now I can use negation introduction to get not Q on line 12, because on the assumption that Q is the case, we get a contradiction. So I get to say not Q by negation introduction, citing lines 8 through 11. And now that I have not P in this scope line, and I have not Q, I can use conjunction introduction to get those two together. So that's conjunction introduction, citing line 7 and line 12. This is introduction. And then, by disjunction introduction, again, now that I have this sentence, I can introduce anything I like. We've proven that that is a truth-preserving rule. So I add on P and Q by disjunction introduction from line 13. And now I have in this scope line, I have a sentence, namely 14, that contradicts the auxiliary assumption in line 2. And since I got a contradiction, I'm going to use negation elimination to take out that negation to get the sentence that I wanted, this guy right here. So this will cite lines 2 through 14. And that completes my derivation of an instance of equivalence. So just to sort of recap here, what I've done is I've assumed this, and I've derived this disjunctive sentence. And now that I've gone one direction, let me actually do the other direction for you too, because I think this will be fairly informative, so you can see the use of disjunction elimination in action. So let me go ahead and do that. So I'm just going to start all over again and pick a different color. And this time, we're going to go the other direction. So in this case, we're going to assume P and Q, or not P and not Q. And our goal is going to be the biconditional, P if and only if Q. Okay, so there's two different ways we can go. One of them is we can start with the biconditional and set up the biconditional, right? So we assume first P, try to get Q, then assume Q, and then get P. Alternatively, we also have this disjunction that we could make use of. So we could, first assume P and Q, try to derive this, the goal, and then assume the second one and try to derive the goal. And both of these are going to be perfectly good ways of going ahead and doing that. And in fact, actually, you'll need to make use of both. They'll just be in a different order. So I'm going to pick, I'm going to use disjunction elimination. So in the first case, I'm going to assume P and Q. And my goal is, I'm not quite sure yet how much space I need. My goal is going to be P if and only if Q. And in the second case, I'm going to assume not P and not Q. So this will be not P and not Q. And my goal again here is going to be P if and only if Q. Okay, so before I have to start thinking about what else I can do, I just noticed that my sub-goals here, and maybe I'm not writing this down here because I'm going to start assuming that you guys have some feel of how this goes, but the reason why I've made this assumption here and here is for the purposes of disjunction elimination. And so this last line here is going to use as its citation line 1 for the purposes of, line 1 and then these two subderivations, because we're using disjunction elimination, right? We're basically saying it doesn't matter whether or not it's this left side that happens to be the case or this right side that happens to be the case that's true. In either case, P if and only if Q. Okay, so now let's look at this sub-goal here. And before I have to make use of anything else in the primary assumption or in this first auxiliary assumption, I notice that this is a biconditional. And the only way that I can get a biconditional is, well, not the only way, but the most common way of getting that is to do biconditional introduction. And so the way I'm going to use biconditional introduction is to first assume that P is the case, and try to get Q. And then I'm going to do the opposite. I'm going to assume that Q is the case, and then I'm going to try to get P. And this is actually going to be relatively short, right? My subgoal now here in this subderivation is Q. And you'll notice, wait a minute, I already have a conjunction. So if I have the conjunction P and Q, I can actually just write down Q by going conjunction elimination, citing line 2. So that's relatively easy. Next, in this subderivation, we need to get, our goal is to get P. And again, I can just use line 2 to get P by using conjunction elimination. And that'll be line 6. And now I'm done, right? All I need to do here is finish citing this disjunction introduction. I just have to cite lines 3 to 4, and then 5 to 6. And so now I've completed this whole subderivation. So I'm more than halfway there. What I now need to do is do this case. And this one's going to be a little bit trickier, and I didn't quite have as much foresight as I was hoping I was because I know that this is going to take us a little bit more room. So let me actually just erase this, assuming that you guys have seen that already. And let me just sort of copy this whole thing so I can make use of a little bit more room. Okay, so what I have up here is not P and not Q. And my goal is to get P if and only if Q. Alright. Now, notice, so remember, I'm just copying this whole thing right here. Okay. So, notice, before I even think about what else I have to do, I notice that the subgoal is a biconditional. And we introduce a biconditional by, in the first case, assuming P and getting Q, and then assuming Q to get P. And I'm purposely leaving less space in here because I'm going to ask you to sort of fill it out, finish this one off on your own, given what we're going to be doing up here, because you're going to be using the same strategy down here as you would up here. So this will be left for you guys to do on your own. So we look at this subderivation and we notice that we need to get Q now as our sub-goal. And we can't do the same strategy that we did before by trying to get, it's not as easy as before, right, by just being able to pluck out one of the conjuncts. What we need to do is we need to try to figure out a way that we can make use of this and P to actually try to get Q. And we kind of seem to be at a loss in terms of being able to make use of anything that's in here, or even our main primary assumption, right? Because the primary assumption here is a disjunct, and we're already in this big disjunction elimination. So we're not really going to be able to make much use of the primary assumption. So as in many cases, we're kind of resolved to using negation elimination. So what we try to do is we assume the negation of the sentence we're trying to get for the purposes of, in this case, negation elimination. Right. So my last line down here is going to be negation elimination. And once I'm in this subderivation, my goal now, in order to be able to do this negation elimination, is to try to get a contradiction. And hopefully you can see that there's actually readily a contradiction at hand, namely not P and P. So I can actually just go reiterate P from this line. I'm not quite sure what line number we're on anymore, so let me just put an arrow to that. And I can do not P again. This time it's going to be by conjunction elimination, where I'll be using this line up here. Now I've got the contradiction, P and not P. And since I started on the assumption of not Q, I can actually just pull out Q. And like I said before, the strategy is going to be the exact same down here as well. So you're going to assume not P for purposes of negation elimination, and then try to make use of Q and not Q to get the contradiction that you need. So given that you've filled in these steps, then we've completed this whole subderivation, right? Because our goal here was P if and only if Q. And those are all the subderivations that we had left to do. Then we can just fill in this disjunction elimination, citing line 1, this big subderivation, lines 2 to 7, and then this whole subderivation as well, to get disjunction elimination as our justification for P if and only if Q. So let's recap what we've done then. The replacement rule that we were sort of checking to make sure it was in fact, that at least an instance of it was a truth-preserving rule, was this line right up here. So it says that whenever you have this biconditional, you can replace it with this disjunction, where the left disjunct is a conjunction of P and Q, and the right disjunct is the conjunction of the negation of each P and Q. And we showed that that was in fact the case, right? I went both in the right direction and also in the left direction. So we've now covered, in some form or another, all of these rules of replacement for this system SD+. So our new system SD+ consists of two things. One was the rules of inference, which we had, I guess I can actually, let me do this. So we had our rules of inference. Make that bigger. We have our rules of inference as an addition to SD, right? So we had modus tollens, we had hypothetical syllogism, and disjunctive syllogism. And then we also have our rules of replacement, which we just went over now, and we just did equivalence. So in the next video, I'm going to go over a few examples that I think are going to help you on the exercises, because some people have requested to just spend a little bit more time going over examples for you guys.